Hello. Now we are going to look at interpreting quadratic graphs. So how to read quadratic graphs. And as an aside, we're also going to look at how to solve these problems more algebraically. But the main focus for now is on the visual element, on how to read these graphs and how to interpret them. So we're talking about quadratic graphs. What would a quadratic be? Well, they will look like a smiley face or a sad face, depending on whether they're positive or negative. And by positive or negative, I mean, is the coefficient of the x squared, is the sign in front of the x squared a positive or a negative? So here we have minus x squared. So this is a negative quadratic. So it's a sad face, a frowny face. This is just x squared. This is a quarter of x squared. They're positive numbers. So we end up with a smiley face for our positive quadratic. And we're going to begin by looking at the roots of our first quadratic. F of x is equal to x squared minus 6x plus 5. So it's a positive quadratic. We can see a smile. And its roots mean where are we crossing the x-axis, or where is y equal to 0. So where is f of x equal to 0? Where is y equal to 0? Where do we cross the x-axis? Now visually from the graph, we can see that we cross the x-axis at 1 and at 5. So all we would have to do is say that this happens at x is equal to 1 and x is equal to 5. Algebraically, we would be looking at our f of x is our y output, so we would be looking at where x squared minus 6x plus 5 would be equal to 0. Where is the y output? And what's the values of x that would make our y output 0? And we would be able to factorize this quadratic in order to find our values of x. From the graph, we know that our answer is going to be x is equal to 1 and x is equal to 5. And I'll write out the steps here. I have not shown every step in this, but it is simply we factorize as we normally would, and we say that each factor multiplied together gives 0. Well, that means that each factor individually could be equal to 0. So that's how we could solve this algebraically, but what we need to be good at right now is visual interpretation. How would we read the graph? Well, we found that when x is 1, y is 0. When x is 5, y is 0. When we go to our graph, that's what we find. X is 1 and x is 5 are the roots of our quadratic. They're where we cross the x-axis. Now, what is the minimum of f of x? That is to say, what's the lowest y output of f of x? Well, if we go to our graph again, we say, well, our graph is going upwards this way, and is going upwards this way, and then down here at the bottom of the valley, at x is 3, and so in the door 3, down the stairs minus 4, we find that we have the lowest value that our green curve goes to. It cannot go below y is equal to minus 4. So that is the minimum of the function. So our minimum happens at y is equal to minus 4, and more often than not we would give that as a coordinate. So it would happen at x is 3, y is minus 4. There's no value of x that we could sub in that would give us a y value lower than minus 4. So it's the minimum of the function. It's the minimum y output of the function. Now, what is f of 2? So f of x is the way we define our function. So f of 2 is what's the value of y when we put in x is 2. So we could sub that in algebraically, and we can also do it visually, which is our main focus for right now. So x is 2. So we go to x is 2, and then we find the coordinate of the graph, this one here, go down, and we would get the coordinate of 2 minus 3. So our output should be, and if we sub that into our quadratic, we got sub in 2 anywhere there was an x, plus 5 we also get -3. But again, we can read this from the graph. When x is 2, we find the y coordinate for when x is 2 on the function, and we get that happens at y is -3. And when we sub into the function, we find that we get the same thing. So this would be an algebraic way of doing it. This is our interpreting the graph way of doing it. Now here we have f of x is equal to 5. So what would that mean algebraically? That means we'd have x squared minus 6x plus 5 would be equal to 5. The y output should be equal to 5. When we were finding the root, we were looking for where f of x was equal to 0. So we set this equal to 0. This time, we're looking at where we would be going to cross the line y is 5. So this dashed line here is y is 5. So we were looking for the root where y was equal to 0. And now we're looking at where y is equal to 5. So where does that happen? That happens when x is 0. X is 0. And it also happens when x is 6. So we know the answer to this is going to be 0 and 6. Now to do this algebraically, we would just try and solve this quadratic. So we know for solving quadratics, we want everything equal to 0. So we'd -5 from both sides, and we'd end up with x squared minus 6x is equal to 0. We have a common factor of x, and we solve. And by solving the algebraic form, we get the exact same answers. X is 0, x is 6. So we can see it algebraically, and we can see how to read it from the graph. If we're asked to do this by interpreting the graph, it is very important that we put in these dashed lines that I've been putting in here to show that we read this information from the graph. This is effectively our workings when we are doing this visually. Now, where is f of x negative? Put another way, when is f of x less than 0? Less than 0 means negative. That is the mathematical way of describing it, and we can see the questions written either in English or in this form. Well, where is f of x negative? F of x is the y output of our function. So in between x is 1 and x is 5 is where our green line would produce negative y values. We can see from our two coordinates here, we have -3, -4 for our y outputs. We'd have -1 at about x is 1.2 or something like that. So we have negative y values when we're below the x-axis. So that's between x is 1 and x is 5. When x is bigger than 5, we start to get positive y values. When x is less than 1, we start to get positive y values. So in between there, when we're underneath the x-axis, is where we get our f of x being negative. And this is quite an important idea going forward. Now moving on to g of x here. What is the axis of symmetry of g of x? Now, what we may notice about our quadratic curves is that they could actually fold onto themselves. If we take our line here, going down through the bottom of the valley here, we would be able to fold the curve onto itself if we folded along that line. Same here, we'd be able to fold this curve onto itself if we folded it along that line, and the same for all of our quadratic curves. They're symmetric in that we can fold them onto themselves on a particular line. And this line is the axis of symmetry, and it goes through the minimum or the maximum. So we can see that that line would be x is equal to 3 would be the axis of symmetry here, and x is equal to 1 would be the equation of our dashed line here that's going through the minimum of our curve. Now, what is g of 5? So we say x is 5, so we go up from x is 5 and find the y coordinate for that, and we go across and we get 7. So we would have the coordinate y is 7. X is 5, y is 7. and that's it done algebraically. G of x is equal to 4. So g of x is equal to 4. When is the y output equal to 4? So we're effectively looking at where does our curve cross the line y equals 4? Well, that happens at x is minus 1, and that happens at x is 3. And that is the quadratic solved algebraically, and we get x is 3 and x is minus 1, same as we did from our graph. Now, where is g of x increasing? Well, that means where is the slope positive? So if we're increasing, that means we're rising as we read from left to right. So on this side of our curve, we're dropping as we read left to right. So the slope would be negative, it's decreasing. But past our minimum point here at x is 1, we start to rise. So anywhere where we would have x greater than 1, we would be increasing in g of x. Now h of x. Where does h intersect L1, our straight line L1? So h intersection L1 is what we are looking for. Well, that happens where they cross each other. So that happens at x is 1, y is minus 4, x is 3, y is minus 2. And we can also solve that because we are looking for where our values of x that would make y equal to each other. And when we set our two functions equal to each other, that's where we'll get the same y value. We solve and we get the same points. X is 3, y minus 2, x is 1, y is minus 4. If we have h of x is minus 7, we are going to the line. We're going to ask ourselves, when is our blue line for h of x crossing y is equal to 7? Well, that happens at what's the coordinate of that point? That would be at about 0.5 and at exactly 4. And solving, rearranging, we get the same values. So again, where is our blue line crossing y is equal to minus 7? We would find the coordinates of this point and this point. So it would be half minus 7 and 4 minus 7. Now, where is L1 greater than or equal to h? So again, these are the y outputs of our function. So where is L1 greater than h? Well, our black line is above our blue line when x is greater than 3 and when x is less than 1. Again, what we're thinking about is, when is the output of the line higher than, bigger than the output of the blue curve? And that's where x is greater than 3 or less than 1. Now finally we have the function k. So what are the roots of k? Well, that means where we're crossing the x-axis, and that is happening at x is minus 4 and x is 0. And that's also what we get when we factorize our quadratic. But our key thing here is to be able to interpret what that means. Our roots are where we are crossing the x-axis. And now we're asked for the axis of symmetry. The axis of symmetry is where we could fold our graph over on itself. And what we may notice is that's halfway between our roots. So halfway between 0 and minus 4 is minus 2. And that is the mirror line. That's the line that we could fold our graph over on. So that's going to be where x is equal to minus 2. Now what's the turning point? The turning point is where we're changing direction. So that's the maximum, the highest point here. That happens at minus 2, 4. Where is k of 1? Well, that means x is 1. So we find the y coordinate and it's minus 5. Where is k of x equal to 3? Well, that happens at minus 1.